Hello, welcome to my office. Well, as you can see, this is a very impromptu setup for me to explain to you lecture quiz number 1. Now, you must be wondering, what on earth is this thing? This thing is my voice recorder. This fluffy thing over here is known as a dead cat. You know the cat, the meow meow? Meow meow, then kena run over by a bus. so kena become very flat, right? So this thing is called a dead cat. It's used to muffle away. You know, sometimes you say words that have a very strong B or P sound, right? So this thing is here to muffle away those sounds, alright? Okay, so welcome to my office. Let me just entertain you. Okay, so as you can see over there here, the window over here, there's a little coconut tree outside, okay? I can't see. Somewhere over here there's a little coconut that's actually half open, and a squirrel actually lives there. And this metal railing is what I call the squirrel highway. Every afternoon and morning you see squirrels running across. It's quite adorable. Now let me explain a couple of things. First of all, there is a terrible annoying bug on Lu minus, okay? So by right, I set up the quiz so that you can see your answer and the correct answer. But this bug will swap the highlighting around, so it will mark the correct answer as the wrong answer, and if you have a wrong answer, you put that as the right answer. So that has caused a lot of confusion among students last week, alright? And so they say, I complained to the Lu minus team, and they say, oh, we cannot reproduce a problem, so we're not going to fix it. Please send us a screenshot if you see it again. Right, so anyway, to avoid this kind of confusion, I decided I will switch off the function so that you can only see the correct answer. You can't see what you wrote, okay? No choice. If they're not going to fix it, what am I supposed to do, right? It caused me a lot of anxiety. I thought I said the wrong quiz answer. Now, I hope you appreciate me explaining the quiz, because most times lecturers don't really want to explain quizzes or give you the answers, because it means that you have the answers, means you can take the answer and give it to your friends next semester. And then there'll be cheating and all that other stuff, which means more work for the lecturer, because the lecturer has to come up with more new quiz questions. So more work for me lah, but I do hope that you learn from this quiz, from the explanation, okay? I think your learning is more important, alright? So, alright, let's begin. So, lecture quiz 1. Alright, so first question is about, ask you about the difference between a problem and a statement about the objective, yeah? Right? So, I ate so much that I can't fit into my new jeans. That is a problem. Is there any hint that you're trying to solve anything? No. How about the second one? I'll reduce my food intake by 30%. This sounds like an objective. Yeah, we're saying something that we're going to solve it. Now, if you turn it around, it can sound like a problem, right? Because you can say, oh, how do I reduce my food intake by 30%? That's true, yeah. Later on, as we go about designing algorithms, you're going to realize that you can have an objective, and then you can define that objective to solve a problem, but then you need to break down what that objective means, right? So that itself becomes a problem to which you will find more objectives to solve, yeah? That is decomposition, yeah? Well, don't worry about that. For now, I would just want you to be able to appreciate and identify the difference, alright? Okay, next option. I require an A+ for this module. Well, I hope you get an A+ too, right? This one is a problem because it doesn't actually say how you go about getting the A+, right? But the next one that comes immediately after the next option, I'm setting aside 10 hours each day to work on this module. That is a statement of the objective. Yeah, I am going to do this in order to get an A+. So, yay, I hope you get an A+ too, alright? Alright, next question. I'm going to go through all the variants, okay? I explained in the lecture videos what is a computable problem and what is not a computable problem, yeah? So here, I want you to be able to distinguish between computable problems and non-computable problems. So, first option, you're visiting Taiwan with 5 friends, you book an Airbnb house, but the house has only one small washing machine. After your first week of stay, your friends begin fighting over who can use the washing machine with each other. Is this a computable problem? If you can come up with a schedule to deconflict who gets to use the washing machine, then yes, it is a computable problem. Now, some of you actually saw me about this. You say, oh yeah, we can come up with a schedule, but then, like if I have a friend that wants to go first and stuff like that. Okay, now, here we are dealing with multiple problems. We have one which is a computable problem, which we can solve by scheduling, and then the other you just have your friends being friends, or being annoying or whatever. That's a social problem. So what we want to do, what I want you to be able to do, is to be able to distinguish what is a some problems are very multifaceted, right? Many different dimensions, right? So from a multifaceted problem like this, can we say, okay, we don't care about whether we have annoying friends, but is there a way that we can at least solve it computationally? Okay, can we come up with a schedule for this? Can, right? Then very good, yeah? So this one, we can compute. Well, if you have a schedule. Of course, we don't care about whether you have annoying friends, okay? Next one. Jessica is currently in Spain and speaks only Chinese. She went hiking and lost her way. Her phone battery is flat too, and she desperately wants to go back to her hotel before the sun goes down. Now, some of you read this and thought, oh, so many constraints must be computable. That's not how you identify whether a problem is computable or not, okay? So here what we're saying, okay, why did we frame it this way? Because the moment you have a phone, all right, what can you do? You can GPS, right? You can use Google Maps, and then you can come up with a set of instructions. Here, you don't have a smartphone. You can't GPS, you can't Google Maps. In which case, it becomes an intractable problem. Because even if you say run to the main road and ask for help, you can't give a proper clear instruction. You can't say run in which direction, run for how long, right? So this is an intractable problem, not computable at all. Okay, next problem. You recently met someone at arts camp. You've grown a liking for that person. You want to ask that person out for a date. Or this is a non-computable problem. It's an intractable problem. How do you even ask someone out for a date? Somebody could give you a magical formula, but it will only work for a class of people, right? So intractable problem, not computable at all. Next one. Marie is planning a trip to eat all the delicious food all over Singapore. She wants to reduce the cost of her travelling so that she can spend more money on food. All that you see here is that Marie is planning a trip. So, but some of the students I speak to, they say if Marie has to plan until like that, then she must be foreigner. Foreigner, therefore intractable problem because she doesn't understand the public transport system. Whoa. Wait a minute, alright? No, you're reading too much. You're putting in too many assumptions into the question, alright? So, first of all, it doesn't matter whether she's foreigner or local, okay? All that matters is that she wants to plan a trip, she wants to reduce the cost of traveling, right? Now, is this computable or not? Actually, it is. It is very, very computable, right? You just need to figure out all the places that you need to go, and then you can work out a set of instructions to figure out how to plan out the trip with the lowest cost. Next question. This is the second version of the same question, right? You just read Marie Kondo and now you want to throw everything in your house that doesn't spark joy. Is this computable? No, it is intractable because how do you even define whether something sparks joy or not, right? In your head, you just... What does Marie Kondo say? She says you touch the thing and if it sparks joy, it sparks joy. Here is a booklet. Very cute, right? Here is a booklet. I touch it. Does it spark joy? Yes, it does spark joy, right? Here, what else do I have? Here are a bunch of documents that are work related. I touch it. Does it spark joy? No. They throw away lah, right? Now, we have a sense here, but if I want you to articulate it, it's not very easy to articulate that into a clear set of instructions. And for that matter, if I ask you, can you say, you come up with a set of instructions, can you apply that universally to all the things that you own, to all the different categories of things that you own? Very difficult, right? What more if we say, okay, now let's generalize it, let's be able to apply this for everyone. Cannot, right? So intractable problem, not computable. Okay, next question. The Office of Student Affairs has assigned one activity room to be shared by 3 clubs. The Silent Reading Club, the Heavy Metal Music Club, and the Noisy Gossipers Against Metal Music Club. Stupid question. Okay, obviously each club cannot carry out the activities in the presence of the other 2 clubs, so the clubs have to decide how to equally divide the timings for sharing the room. Computable? Very computable, right? All we have to do is just come up with some kind of deconflicting schedule. In fact, if you watch lecture 4.1, I taught you the computational way of solving it, right? That little drama over the birthday, right? So you just draw your circles and color it, and then ta-da, you found a way to deconflict already, yeah? So this one, very computable. Of course, you might say, oh, but then this club wants it on Monday or whatever. Okay, side issue. That one you still can solve the problem using a computational way, yeah? Okay. Next one. You and your friends are preparing to go on student exchange program. You all have many different things to pack. Computable? Yes or no? It's a bit hard to compute well. I mean, you could come up with a set of instructions, but it's hard to compute well because, well, do you know what you want to pack for exchange? Well, there are things that you don't know, right? Right? Some things you don't even know exactly where to pack, especially if you go to a winter country. You grow up in Singapore, no winter, don't even know how much to pack, right? Some of you pack, you go to a place where the winter is like 10 degrees Celsius, and then you're packing like you're going for Siberia, right? Now, okay, anyway, the point is this. That it's not easy to even come up with a set of instructions that's generalizable for yourself or even for other people. So it's not easy in this situation to come up with a computable solution. Unless you and your friend, you're very similar and your needs are very basic. Then in which case, yeah, okay, you can come up with an algorithm. But in most cases, absolutely not, right? You don't know what to pack. You have 101 things that you feel you should bring with you, right? Okay, I'm talking a lot. Okay, next option. You are driving to NUS from Changi. 3 of your friends who live in different parts of the island are asking you to give them a lift. Computable? Very computable, right? Just 3 people from Changi. Done, right? Okay. Next question. Now, I talk about constraint approach and optimization approach. Okay, so this questions is to help you identify the differences between a constraint approach and an optimization approach. Now, let me start first of all by saying this. Okay, whether you're solving by optimization or by constraints, problems will always have constraints of their own, right? For example, a day has 24 hours. So your constraint is that each day has 24 hours. I can solve a problem. Let's say I want to set aside time for study, right? I can set aside 5 hours a day to study, right? Then that is a constrained approach to studying. But let's say I could also say, it's very hard to set a constraint, so maybe I will optimize. I'll try to study as many hours as possible within 24 hours, right? In which case I am solving by optimization. So the presence of constraints alone do not actually indicate whether something is a constraint problem. Yeah, you can still optimize in spite of constraints. In fact, having constraints can help you optimize better. Yeah. Okay, let's look at the first one. I have $4 to spend today. I'll just spend $3.75 on dinner since this is a meal I can afford here. There is no explicit intention to maximize or minimize, right? When you're optimizing, you're trying to maximize or minimize. Here, you're not doing anything of that sort. It so happens that this food is $3.75. Okay, next one. I cram all my classes into the fewest possible days so that I have more free time to myself. Notice the use of the word fewest possible days, yeah? Fewest is an explicit intention to optimize, yeah? Next one, I'm running late for my 8 a.m. tutorial. I'll book a Grab car. It costs the most, but it'll get me to campus the fastest. What's the intention? I want to get to campus the fastest. Minimize travel time, right? This one, optimization. Next one, as a full-time student, I'm legally allowed to work a maximum of 16 hours a week. Okay, now some of you saw the word maximum of 16 hours a week and then you immediately assume it to be optimization. No, here, maximum of 16 hours a week is the constraint, right? That is the upper bound limit of how many hours you can work. Here, the person says, I want money, I'll just work 16 hours a week then. It is not optimization because here the person is not explicitly stating an intention to optimize. It is just coincidental that it is 16 hours, yeah? No explicit expression in the question. There was no optimization. But why do you assume that there's optimization? Because most of the time, we actually carry out optimization to a lot of the problems without realizing it. The point of the question when I said this was to help make you become more aware of how we optimize. We try to solve problems by optimization a lot of times in our lives, yeah? Okay, next option. I decided to limit my caffeine intake to 1 cup a day. Since 2 cups or more will make my hand tremble for hours. Again, no explicit intention to optimize, so this is just constraint. Okay, next one. Joey consumed 2.8 GB out of her 3 GB mobile data plan scrolling Instagram without her Wi-Fi turned on. Wow, sucks to be you, right? If you are in that situation. She still has another 29 days to go before her 3 GB of data resets. Now, this story is very detailed because why? Story of my life, yeah? Hashtag FML. Okay, anyway, so she doesn't want to pay another $9 per GB just for exceeding her data plan, but she still wants to use her remaining data when she has no Wi-Fi. She decides to keep her social media usage to a minimum when she needs to use her mobile data. Notice the explicit expression, usage to a minimum. So this one is optimization, not constraint. Next one, everyone's busy, so let's make sure we always have at least 2 club member stations to sell bubble tea for this week. At least 2, the lower bound limit, yeah? So in which case, this is a constraint approach. Next one, Shannon accidentally spilled mala sauce on his dress shirt during lunch on the day of his project presentation. So moral of the story, don't eat mala or anything with gravy, yeah? He wants to go back to his room in Fong Sing Residential Hall. Which one is Fong Sing Residential Hall? You guess lah. Okay, he has only 20 minutes to spare before his group presents. He doesn't think he can make it back in time, so he decides not to do anything about it. Here, we have a limit, right? Which is 20 minutes. 20 minutes to go get changed and come back for presentation. This is a constraint, and because the fella cannot meet the constraint, right? So what does he do? Don't do lah, right? Cannot make it back in time, so don't go, right? So this is solving by constraint. Next one, Alexandra, or if you're Spanish speaking, that is Alejandra, is looking for the prettiest pair of spectacles. After searching high and low, she finally finds one and makes the purchase. Not even relevant, right? Okay, next one. This membership card will triple the number of air miles I get, provided I spend at least $200 for the month. At least $200 for the month is a constraint. But notice what goes on next. Since I'm dying for a next free trip to Japan, I'll spend as much money as I can every day. As much money as I can. So here there is explicit intention to optimize. Yeah. Some of you are confused by the at least $200 for the month. So you get more air miles if you spend on the condition that you spend as much money but more than $200 every month lah. By the way, next time you go out and work, get a credit card with air miles. Then every time you spend, you pay bills or whatever. Especially when you pay for wedding. Then you get enough air miles. You can go on a free honeymoon vacation. That's a good idea. That's what I did, by the way. Haha. Okay, life hack. Okay, next question. Which of the following is optimization? Okay, this Eileen story is the same as before, so I won't go through. Yeah, this one's optimization. Next one, everyone's busy. Okay, it's the same story, right? So this is constraint. Okay, next one, Kevin accidentally. Okay, I just changed the name. So this one is what? Constraint, right? Not optimization. Next one, membership card. It's essentially the same question lah. I just changed it from asking which one is constraint to which one is optimization. Okay, so we're done with this question. Okay, next one. Which of the following is solving by optimization? I only have $4 to spend. I'll just spend $3.75 on dinner since this is a meal I can afford here. Constraint. It so happens that the first item is the first item this person sees is $3.75. If it says that this is the cheapest option available, then you are solving by optimization. Of course, some of you feel that this is optimization. Why? It's actually constraint, but why do some of you feel that it is optimization? Because if you settle for the first thing that's under $4, then what's going on in your head? Maybe you are rushing for time, so you're trying to optimize, you're trying to minimize the time taken to buy food. But here, there's no explicit mention of this, so we cannot just assume it, right? Next one, I cram all my classes into the fewest possible days so that I have more free time to myself. This one optimization, right? Oh, it is actually a rehash of the earlier question, right? Running late for my 8 a.m. Fastest. I want to get to campus the fastest, so that's optimization. Next one, go to JB with friends. Reduce travel time. Minimize travel time, so optimization. I decided to limit my caffeine intake to 1 cup a day. Constraint. Yeah. Oh, we've come to the end. Okay, so that's all the explanation I have for lecture quiz 1. I'll give you the explanation for lecture quiz 2 very soon. So all the best and take care. See you.